Okay, very short presentation of mono2micro, where the code-based representations were already obtained from using the collectors. So I'll start by creating a code base that will be the code base for quizzes. I create the code base, and then I basically add representation files. These representation files were already obtained, so I have the accesses, each one that was obtained using the static analyzer, and I'm gonna import them. So these are JSON files that have the sequence of accesses, this one, and then one that associates the IDs with the entities, which is this one. Okay, I submit. I'm gonna add the ones that were used by analyzing the logs in Git, so the repository based. So the ones that describe who are the developers that changed, which files the developers changed, and ones that say for each file which other files are changed together, so they are in the same commit. Okay, and I put information here and I submit. Now I define a strategy, and when I define strategy, I choose one algorithm. The only algorithm we have implemented so far is the sci-fi. Okay, that are using the sci-fi, which is a hierarchical clustering algorithm. So when I select there, I can decide which representations I'm going to use. In this case, I'm going to use both. Okay, now I can create the compositions. Basically what I do, I go through the manual setup and I define, for instance, what are the weights for each one of the similarity measures. These are predefined. The sum should be 100. But I can do it differently. I can basically use the recommender, and the recommender basically is going to do all the possible combinations. Okay, and this is going to generate 1000 combinations of values. Okay, so that we can see which one has the best complexity. So we have to wait a little bit. So already I have here a couple, but we'll get more and more because, okay. Now I can choose the best decomposition, considering, for instance, 5 clusters. So it's 5 candidate microservices. When I do this, then I can decide which is the best. So I can get more there. We are already 100 something, refresh, 200, okay. So I can choose the best one, for instance, in terms of complexity or in terms of coupling. I can pick the best value, so the best decomposition. In this case, let's pick this one, okay. It results from these weights for the different similarity measures, okay. And now I can just pick there and I can create the decomposition. Of course, it is continuing to generate more decompositions. So when I fish this here, I get the decomposition, and basically now I just can view it according to different types of decomposition representations, either in terms of accesses or the repository views. So in this case, I get these, and I also can see the metrics for this decomposition, and basically the metrics are here, okay, in terms of each one of the clusters, what is the complexity of each one of the clusters, squeezing and coupling. And I can also go here and see a view in terms of functionalities. So I can see, for instance, functionality that access the 4 clusters, and I can, for instance, just the create quiz. And I see, so the create quiz functionality accesses this cluster, and I can see which entities it accesses in each one of the clusters. Of course, I can have another view where is basically the sequence of accesses, and I see for this functionality which entities in terms of read and write access in each one of the clusters. Another thing that we can do basically, we can have metrics for this. So these are the metrics for each one, and the metrics in terms of if it's going to be implemented as a query or a saga. Okay. And we have here the metrics for each one of the functionalities. We can even redesign the functionalities, and for instance I can create a new redesign and I can get something. So this is basically the sequence of accesses. It is being done in each one of the clusters, and I can do things like, for instance, I can just redefine, for instance, let me make it a bit smaller. I can just redefine, for instance, the sequence. I can say, okay, let's this, and say that is invoking in this, but let's suppose that then it invokes in different order. So this cluster invokes that cluster, that cluster, that cluster, and then I have this cluster there. Okay, so I want to invoke this, and then instead of this cluster invoking this one, is the top one that invokes. So this is a change, sequence change, and I'm gonna pick this as the one. Okay, that's cluster 0. Oh, sorry, cancel. It's the opposite, so I need to select this first. And I do change sequence, and I pick this one. Okay, submit. So, and it creates this. I can do other operations like collapsing when I have a granularity, high granularity. So for instance, I can just, if we look there, we'll see that it keeps invoking the same cluster. So I have 4, 2, 4, 2, 4, 2. So this is like fine-grained invocations between clusters, and I can try to create a coarse-grained invocation. So what I can do here is I just do this, and I select define a coarse-grained interaction, and basically to cluster 2, and I say is 2 here, then I have cluster 2, then I have cluster 4, then cluster 2 again. It goes till 7. I think it's okay. No, it's 2, 4, 5, 5, 6, and finally 7. Okay, let's do it. And then now everything is collapsed here. Okay, so this branch was collapsed there in this invocation here. Okay, so but this is pretty tedious, and I don't believe that someone is going to use it for a real system, because this can be really long. So we defined another thing that is the ability to do it automatic refactorings. So we have this refactoring tool that basically what it does is I come here and it just gives me suggestions. So it recommends what is the best refactoring of the functionality. For instance, for this create question, or I think it was create quiz we are looking at, we'll see that now is much. So he has done these operations automatically, and it suggests that probably this is the correct sequence. Finally, we can also play with this. So I can, for instance, expand the cluster, and I see which entities are inside expand this cluster, and for just for one entity or a cluster, I can just show only the neighbors so that I can visualize what are the interactions between these and that. I can even collapse to clusters. For instance, let's just do this. Show all. Now let's collapse into cluster, and I can basically, for instance, merge cluster 1 with clusters 3, and let's call it 1 plus 3 merge, and it's there. Okay, and now if I go to the matrix, it recalculates the matrix according to the new structure. Oops. According to the new structure. And basically you can do several operations here, this type of operations. You can rename, you can split, you can transfer entities between clusters, and you can set. Okay. We can do something else here. It's here. So recommendation, manual setup. Oh, we have comparison tool there. Here, I can basically pick two decompositions and put them together, compare them. So let's create another decomposition. So if I go to the code base, manage code base, I'm gonna create one by using just values I put there. Let's say 20. 30, and put here 20 and the 0, and generate. Okay, so I have another cluster here. So these are the dendrograms that are generated, but now I can create here a different decomposition, generate the decomposition. So I'm gonna define a cut, say like, let's say a cut where I have 5 clusters as well, generate, and I have another decomposition here. But now, what I actually can do, I can come here, and I select the code base, and actually I can compare the two decompositions. Okay. And it's gonna show me the module FM distance, which is the number of operations you need to do to transform one cluster into the other one. So, and then we have the entity pairs, false positive, false negative. This helps you if you, for instance, you select one that is the expert decomposition, and when you compare with the automatic generated decomposition, you will see which ones where the entities are in the same clusters or not. Okay, so that's it.